this video on the double angle formulas. These are basically just a special case of the compound angle formulas. So in the double angle formula, all it means is that the angle is doubled, and so it means that each of the two angles are the same. So where we have sine x plus y or cos x plus y or tan x plus y, we can really think of that as sine x plus x or cos x plus x and so on. So I'm just going to start filling this out over here. So sine of x plus x, so double the angle, is equal to, now when we have x plus x, well, we can just say that is sine of 2x. And if I substitute the x in for a y in the right hand side of the equation, it gives sine x cos x plus cos x sine x, which those are both the same thing, and so we can just say that is 2 sine x cos x. Now it'll be the same thing for these other ones. So the cos double angle formula does have a couple of different forms. So if we do cos of 2x, we're just substituting in that x for y again, and so that gives us cos x, which is going to be cos squared x, minus sine x, which would be sine squared x. So cos squared x minus sine squared x. Now that's one form of it. The next form, we can make substitutions using the Pythagorean identity. You might remember the Pythagorean identity is sine squared x plus cos squared x equals 1. So we can rearrange that to either get sine squared x by itself as 1 minus cos squared x, or we can rearrange it to get cos squared x by itself as 1 minus sine squared x. Okay, so we're going to make both those substitutions in here. So if you replace the cos squared x first, replace it with 1 minus sine squared x, then that's going to give us 1 minus sine squared x and then minus another sine squared x, which means we have 1 minus 2 sine squared x. The other alternative in that first line is to replace the sine squared x with 1 minus cos squared x. And so I've got cos squared x now minus 1 minus cos squared x, which works out to be 2 cos squared x minus 1. So there's those three different forms for the cos double angle formula. And the last one is for tan. So making that y just x, we get tan 2x equals tan x plus tan x is 2 tan x over 1 plus, and tan x is the same as tan squared x. Now you could also use a Pythagorean identity to change that denominator into a different form there, but it's not really common to do that. Not to say it's impossible, you might encounter that, but yeah, just not all that common. So I've got a quick question down here. So simplify sine 2x over 1 plus cos 2x, and hence evaluate tan to 15 degrees, and we'll be able to get an exact value for that. So sine 2x over 1 plus cos 2x equals, now the sine 2x was 2 sine x cos x. Divided by, and we're going to have 1 plus, now cos 2x, I can choose any of those forms there. I'm thinking it's probably going to be best if I cancel out the 1, just because that could be a little bit of an annoyance there. So I'm going to replace the cos 2x with 2 cos squared x minus 1. So we can see that the 1's cancel each other out there. Also, these 2's will cancel each other out. and the cos squared will cancel out with one of the coses there. So we're really just left with sin x on cos x, which is tan x. So that was quite nice. And from there we need to evaluate tan of 15 degrees. Well, what we can see then is that x must be 15 degrees. So when x equals 15 degrees, then we're going to get tan 15 equaling, and well, I've got sine of 2 times 15, just using this left hand side of the equation here, over 1 plus cos of 2 times 15. And we know those exact values, so sine of 30 degrees should be half over 1 plus root 3 on 2, which we should tidy that up a bit. So I'll leave it as half over 2 plus root 3 all over 2. And then these halves will cancel out. So we could write it as 1 over 2 plus root 3. Or if we wanted to rationalize the denominator and get a much nicer answer here, we can multiply by the conjugate. So multiply by 2 minus root 3 on 2 minus root 3. And in the numerator there, sorry, we have 2 minus root 3. In the denominator, we're going to have 4 minus 3, which works out beautifully to just be 1. So our whole thing just works out to be 2 minus root 3. So there we have it. That's tan 15 degrees as an exact value. I'll leave this video here. We'll come back with some compound angle practice in the next one. See you.